Cool.
Yeah.
10 o'clock, so I started the recording. I don't know if we want to pause it and wait for other people to come.
So I have two directions that we could pursue, among others. One is to sort of integrate this with the locker with real signatures and stuff. And the other is to sort of do a more fine-grained code review and intersperse the Solidity with the rholang.
I'm more in tune with that one. To getting more comfortable with rholang for me is a good thing. Although I would be interested at some point getting a better understanding of what the locker is and what it can do.
Right.
So maybe save that for the end of the session. But Jim, do you have a preference?
Not really. I'm game for anything. I'm, as I was saying before, we had a late night of watching silly TV stuff.
Yeah.
I'm not really awake this morning.
You can drink water, just a second.
Uh-huh.
All right. I'm inclined to just go ahead and start and encourage you to slow me down at any point, Steve, for the benefit of others who might watch the recording.
Okay.
Let's stick share screen. Stick this over here. Get rid of that. Maybe we'll take notes there a little bit. Oops. Okay.
So this voting contract, you pretty much modeled it directly after Solidity contract?
Absolutely. Yeah. I don't have much experience with Solidity. I don't know if anybody else does.
Yeah.
You do?
No.
Oh, okay. All right. But it's kind of a normal-ish programming language, I assume. All right.
Yeah, I had some experience with it. Of course, they kept changing the standard, the norms on me.
Okay, so in fact, the Solidity contract, I copied it down here. We'll just we'll copy it a little bit at a time. This is boring enough to delete, right? Okay, so this, all right, in Solidity, you just say contract ballot and off you go. But in rholang, before you can say contract ballot, you have to say new ballot.
Okay. And that creates the channel?
Yes.
Okay.
All right. And then since this is kind of a large random number, and once it goes out of scope, oh, let me do this too. Let me run it to show what goes on here. That's a previous run, which is the same thing, but okay. Okay, rnode eval voting.row. Okay. So we'll walk through the code and the little bit of other stuff at the same time. Okay, so here we're going to allocate. Whenever you call a function, you have to allocate a channel for the return. At some point, Greg explained it as labeling the function call sites. Anyway, so rholang is like that.
Okay.
So ballot is registered at here, and if I run this again, it'll register it at a different address. But if the idea is that you deploy the code once, and then you can call it by looking up this in the registry.
Okay.
And I would publish this name on the moon or whatever. All right, and so that did a insert arbitrary, which is a sort of a built-in doodad. The registry is a feature of the system. And morning, David. We're just sort of warming up.
Hey, David.
Hey, it's good to see you guys.
Yes, good seeing you. Happy New Year.
Happy New Year.
Happy New Year. Yeah.
So the return channel is the URI channel, and then this ballot is one of the arguments. And we send processes and receive names. And when you do a new, you get a name. So if you want to turn a name into a process, you put star in front of it, sort of dereference it. So in parallel with the insert arbitrary, we listen for the return. And when we get the return, we print it out. So far, so good?
Yes.
All right. So this, go ahead.
Yes, I'm good.
All right. Awesome. When you deploy stuff in Ethereum, you don't know what the address is going to be until after you deploy it, true?
That's correct. Well, let's see. I think you can get the transaction hash before send it.
Yeah, but a transaction hash is different from an address. Transaction hash is much longer. Okay. All right, and then the solidity stuff says, let's see. Okay. So they're going to make a data structure called voter, which has got weight and whether you voted, and here you're delegating to, and which proposal you voted for. I suppose that's really not, that's more like this. Okay, so
The contract, we do have to still deploy in order to get the contract out there, right?
yeah, I'm testing in this eval mode where you're not really using the consensus chain. I'm just using the interpreter. But yeah, we would normally rnode deploy and rnode propose. We could test that in a little while. Does anybody have a network we can share on?
No.
You can run on rnode. Robot.net, although it's I guess technically it's really standalone. I mean, there's lots of things connecting to it, but they're not cooperating.
Okay. So maybe I'll do that later. All right. Where's the constructor? This is stuff is going to get out of order a little bit. So in Solidity, the constructor, you call it with an array of proposal names, each of which is an array of, I don't know, a byte's 32, whatever that is. Maybe it's 4 bytes or something, a 32 byte or 32 bit, something. Anyway, you give it these tokens that are proposal names. And then in Ethereum, you can always get the message sender. And so they assign the chairperson to the message sender, and then they have this voters array. Where was the voters array?
It's mapping.
Yeah. So there's all this stuff here. Anyway, there's a public address that's the chairperson. There's a mapping of address to voter, which is called voters. And when you call the constructor, it sets the chairperson to the address of the sender, and it gives the chairperson a weight of 1. Okay, so when I call the contract, it's kind of like the constructor. And what this does is it says this is a pattern, and this side binds, just like a normal argument to the constructor, just like this part. And then this says it also has to be a set with a head and a tail. That is, it's a non-empty set. Does that make sense?
Yes.
All right. And then you have to give us a return channel. And what we're going to do is allocate a bunch of stuff, chairperson, and then there's a winning proposal name function. And then these channels are places to sort of store things. And we are going to give you back on the return channel the chairperson and the winning proposal name wrapped in such a way that you can only send to the chairperson and the winning proposal name. You can't read from them. You can't because reading from them would redefine what they do. Does that make sense?
Yes. Yes.
Because contract is a synonym for, it's a syntactic sugar for listening on this name. All right. So they do this structure in a mapping. Let's put this down here. And I instead initialized a bunch of individual maps. I wonder if I could have done it the other way, but anyway, I did it this way. It seems to work. All right. Okay, so one of the things we might notice is different already is that in the sort of rholang object capabilities world, what happens when you call this contract is you get sort of a capability back. You get the capability to act as the chairperson. So you don't need a public key or anything. the fact that this is a new unforgeable name means that it's, if you have it, you were the guy who called the contract, the ballot contract. And if you give that away, then somebody else can act as the chairperson, but otherwise you're the only one who can act as the chairperson.
Okay.
And at first you're the only one who can ask for the winning proposal name, but it's fine to give out winning proposal name to anybody. Anybody can ask who won or who's winning. But you better not give out the chairperson thing unless you really meant it, right?
Right, right.
So those are separate capabilities. All right, so now we've got some maps for voter weight, voted channel, count channel, and delegate channel. So these probably could use better documentation really quick. From bundle 0 of voter. Oops. To and this one is a map from, let's say, voter ID.
What's a bundle 0 again?
It's something you can't receive from nor send to. It's an only, so it only serves to distinguish one thing from another. We'll get into that soon.
Dan, is it possible to remove the participants on your screen? So, because I'm part of the participants is covering up your typing.
I think that's on your screen.
Well, you're sharing. So if I, here, let me. Okay, well.
I don't see the participants over this part of the screen.
No. Oh, do you have two screens or one screen?
I have two.
Two. Yeah, I have one, so I think it's combining everything into one screen.
Well, you can move your participants window around, I think. Oh, you mean if I did that, does that change anything on you, for you?
Here, okay. I just messed my screen up here. Bear with me.
Okay.
Go ahead. I'll figure something out here.
No, you're kind of my audience, so. If I'm moving the participants thing around on my screen now, does this make any difference to you?
Yeah. Well, what's happened is their share screen went. Oh, okay. 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 Good. I made some changes, so now it's it's better on my side. So I didn't realize I could do that. Okay, I'm good now.
All right. The count tells us for each proposal how much voter or voter weight is on there, and this is from voter ID to delegate voter ID. All right, and they all start out empty. All right. So then we listen on the chairperson channel, and if somebody sends the string give right to vote in the return channel, then I'm going to allocate a new voter. And here I've got a comment that says voter is perhaps a misnomer. It's not really a person. It's really a voting right. And this chairperson is the chair, the right to act as chair. It's not really making a new person. And even thinking of it as a person maybe will kind of mess you up. But I wrote the code this way, so maybe we'll change it later, or we can change it now if anybody insists. Okay. And then one, so a lot of times things don't work. Like if you just forget if you get the number of arguments wrong in rholang, you don't get an error message, you get just no progress. And so one of the techniques I end up doing is when things aren't going quite right is I put a trace inside every 4 so that I can see which 4s get executed and which ones don't.
Oh, okay.
So here we see chairperson gives right to vote. Let's see, did we print the chairperson? I think at the bottom in the example. No. Where's ballot return? Oh, there it is. Yeah. So here's our example down here. And after it calls ballot, it prints out what ballot returned. So we did our registered earlier, and here's our ballot returned. One thing you got to be aware of is that these outputs can come in sort of any order, except for they're ordered by data dependency, but if things are running in parallel here, then they can come in any order over here. All right. So now we know who the chairperson is, and then each time give right to vote is called, we see chairperson gives right to vote. Our chair gives right to vote, so there's 3 of those. That's because the demo down here has 3. Okay. And then the next bit is somewhat copy this up here. Okay, so there, so they have this require thing. We don't have that in rholang. Basically, in Solidity, I guess things kind of run in a transaction, and if anything bad happens, the whole transaction rolls back.
Okay.
All the storage and stuff. Okay, so they have to require only the chairperson can give to right to vote. We don't, because if you have the unforgeable name chairperson, then you have the right to vote. That's just the way it is. That's the way capabilities work. So we don't have to check that explicitly. Does that make sense?
Yeah, I'm following.
Okay. Okay, they also have, if this, okay, so they have to check that the caller or that the guy who the chair is giving the right to vote to hasn't already voted, but it's not possible that this new voter has already voted because he's new, right?
Mm-hmm. Okay.
So we don't have to do that either. And then
So in rholang, it's able to make that determination that the new voter is a unique voter that they haven't voted before.
Well, it's just sort of, we just don't have to, because this is necessarily a channel that's never existed in the universe before.
Okay.
So it's not possible that that thing is voted. It's never done anything.
Gotcha.
It's a brand new baby or whatever.
Yep.
So we don't have to check for that. We also don't have to set their weight to 0. We just, they're not in the map. So
Okay.
Okay. So then they set the voter weight to 1. So this is the way we set the voter weight to 1. rholang's data structures are all immutable. The only thing that's mutable is sending data on channels. So what we do is we listen on this voter weight channel and we get the map, this immutable map thing.
Okay.
And then doing a set on the map basically gives us a new map with this entry set to that. And so we put that back in the channel.
Okay.
And then we are going to use bundle 0 of the voter. That should be explained someplace. This is the part where it really matters. So we've got the ability to delegate. And if I want you to delegate your vote to me, I should give you something like my voting token. But I don't. Let's see. Maybe this would be simpler if I just gave you my voting token. But anyway, I'm not going to give you my voting token. I'm going to give you sort of this attenuated version of my voting token that's bundle 0. In other words, it doesn't allow you to do anything. It doesn't allow you to exercise my right to vote. It just allows you to recognize it.
Interesting. Okay.
Right. So we're going to do all of our comparisons between voting rights on bundle 0s. I don't know how to write that in a comment. So, okay. Then, so that was the give right to vote thing. Then they've got their actual vote. Got a question?
Yeah, I was just thinking about that give right to vote when you gave the example of you giving me the token so I can see how you vote. That's provided that neither one of us is the chairperson. We're just two people out there voting. You have the right to vote, and you want me to see what you vote, how you vote.
It's not that I want to see how you voted, although that might end up being some kind of consequence or whatever. It's that I want you to delegate your vote to me. So I have to give you some sense of who I am.
Okay.
I have to allow the chairperson to recognize that you're voting, you're delegating your vote to me.
Oh, okay. Okay. That makes it more clear. So you provide me with the token, and that allows I give you that ability to
Right.
vote. Okay.
Yeah, we'll see the delegate method in a little bit.
Okay.
All right. So in Solidity to vote, you call vote with which proposal, and it looks up your voter structure, and it checks that you haven't already voted. Oh, it checks that you have the right to vote, checks that you haven't already voted, and if that's all set, and it says you voted, and it says which one, and then it bumps up the count for that proposal.
Okay.
All right, so in rholang, let's see. So again, we don't have to do this part, because if you have the voter, if you have this voter name, then you have the right to vote. We don't have to check that your public key is anything special or whatever. It's just the way capabilities work. So we don't have to check that anybody has a right. Possession, possession is not 9/10 of the law; it's 10/10 of the law in rholang.
Oh, right. Yeah.
Okay. And then this is an idiom I've come up with, which is that, first of all, if the return channel, if you don't send any information on the return channel, I call it ACK instead of return. And then the other thing is that if the method is partial, that is, if you don't always get an ACK, if there's any way to, if there are any sort of error conditions, then I send back that on the eject channel instead of on the ACK channel. It's also possible to do, use some kind of data structure thing to distinguish errors from normal returns, but I'm doing it this way for now. It's kind of the habit I've gotten into.
Okay.
Okay, so we do check for unknown proposals in the same way that these guys do, or don't, do they? Oh, right. This says that if there's an unknown proposal, that will throw. So we check to make sure that you're voting on one of the actual proposals that's available. And if you're voting for one of the proposals, then we go grab the map of what people have voted for. And if you're already in that map, then you already voted. So one of the trickiest parts of rholang is that we took this thing out of this channel, and we got to remember to put it back.
Right.
Yeah. So eventually the type checker is going to help us with that, but we don't really have a type checker yet.
Okay.
I'll show you some really cool type checker stuff. Oh.
The peak operation will also address that, right?
Yes. Well, not in this case, because I'm not peaking. I'm actually going to change the voted for thing in some cases. Link to Zoom. Can somebody give Piers the link to Zoom? Or did he get it already? That's doing the thing.
If I can find it.
Here, let me.
There it is.
Okay.
You got it.
Okay, so if things go well, I'm actually going to change. You're voting, so I'm actually going to change the voted for map. So this is not just a peak. This is actually we're going to do an update.
And I'm not familiar with peak. How is that being defined?
Peak is get something out of a channel and leave it there.
Okay, and is that peak P-E-E-K or P-I-Q-U-E?
The former, P-E-E-K. And it looks something like this or something, I can't remember, but it's not implemented yet.
Okay.
All right. All right, so we do have to check that you already voted. There are other ways to neuter the ability to vote twice. We could use a channel that's already been sucked out of or something, but then you would just get no progress. It's sort of friendly to actually get some indication back that you already voted. Anyway, okay, so now we've checked that you've got a good proposal and that you haven't already voted. And now we're going to go grab the proposal vote counts and the voter weight counts. And we're going to trace for sanity. So here we have proposal, Lincoln, voter, unforgeable, blah, 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 weight 2. And let's go look at our example. Yes, the solidity thing doesn't have an example, but okay. So our example is new ballot channel, voter 1, channel voter 2, channel voter 3 channel. We're going to call ballot on the sync a set of Lincoln and Douglas. For anybody not steeped in U.S. history, that's President Abe Lincoln, big good guy, and Douglas, the guy he ran against. At least that's their surnames.
Mm-hmm.
And then the ballot contract is going to give us back this right to be the chairperson and the ability to check who won. And then we're going to make up 3 voting rights, and we're going to go grab those 3 voting rights from those channels. And then voter 3 is going to delegate to voter 2, and he's going to try to delegate to himself. And when he tries to delegate to himself, he's going to lose. And then because he's delegated to voter 2, there's a guy who gets weight 2 when he votes. And then after the delegate has happened, I could have done these all 3 in parallel, but then you get different kinds of races. Anyway, then sometimes the delegate happens and sometimes it doesn't. And anyway, all right. So then the first voting right is exercised for Douglas and for Lincoln in a race. Who knows which one happens? And the guy votes for Abe Lincoln, which is not one of the choices. So you get unknown proposal Abe Lincoln. And then when both of the votes have been exercised, then we go find out who won and trace that. So the winner, and the winning proposal name, I've sort of changed something, and it gives you back both the winning proposal name and the tally. So I can make that nicer a little bit, if you like. Okay, so when we left our hero, we were in the vote method. That is, if you send to the voter channel the string vote and a proposal and a couple other channels, and we checked all the preconditions, and we did a trace. Okay, and then now this is a peak. So we just grab the voter weight thing out and we put it right back. We don't change it at all. And we tell the caller that he won. And I don't know why I did it in that order. Maybe I tend to do peaks first, but and then we record who the voter voted for, which proposal the voter voted for. So we take the map and we add the kind of voter ID. It might be nice to factor out this voter ID thing so that I don't have to keep writing bundle 0 and don't have the possibility of forgetting to write it. That would be an enhancement, but not for now. So we record which proposal this guy voted for, and then, count equals count plus 1 is a little bit elaborate. It's a little bit of a mouthful. You take the count, and you set at the key for the proposal. You get the former count, and if the proposal's not even in the map, if nobody has voted for it, then you get or else 0. And then we're going to get the voter weight for this voter, and then I don't know, just in case something horrible went wrong, I put 0 there. I'm pretty sure it's impossible. I'm pretty sure I could have just written get there, but so this is basically saying, here's the old count for the proposal, here's the voter weight, add them together, put them at that place in the key, store it back in this channel.
Okay.
So that's basically doing this bit.
Quick question where you the line. So I understand where you put in the peak for the voter weight channel, and then right after that you have AC, bang, nil. And what was the purpose of that part?
This is kind of the return statement.
Okay.
So if it helps you, I can write it this way instead. But you don't really want to get into the habit of thinking that this happens after these. It happens in parallel.
Okay, that's fine. That's fine. That's, I think, what I needed to understand, that happens in parallel.
Right. It's all these bars here.
Yeah. Yeah. I need to look further to the right to see the bars.
Mm-hmm. Just for fun, David, are you following along so far?
Yeah, of course. Yeah.
Okay, good. All right. Voting stuff was straightforward. Delegate took me a little while longer. Delegate, that is. So let's go and look at the delegate thing. Somebody just...
I guess one quick question there. Because you're returning the ACK in parallel, aren't we risking accessing the vote channel before it's written?
That's a very good question, and it does take your head. It takes a while to get your head around this. But which channel were you asking about?
Well, both the vote channel, actually all of them. The Vote We Rights channel, the vote channel, the count channel.
Okay, well, nobody else can get anything out of this channel until we put something back in there.
That's true. Okay. Right.
Yeah, when we take stuff out of the channel, then there's nothing on that channel.
Right.
It's kind of wild the way the synchronization works. You don't need any locks or anything. Well, each channel is its own lock.
Right. Yeah. It's easy to forget how that works. Right?
Yeah. And it makes a huge difference whether you do, this 4 separate from these 2. Notice that these 2 happen together. So I'm either going to get both of them or, neither. And all that, you want to really think carefully about it. And you want to make sure that, for example, none of this could possibly fail, because I've just told the guy that he won in parallel.
Right.
So I check all my preconditions before I tell him he's winning. Yeah, but in some sense, he may get notified that he won before these channels are written, but it doesn't matter. Nobody can read from those channels until I've written to them. Yeah. Okay, so now here's the delegate method in Solidity. We're going to delegate to somebody by their address. So we're going to look up the message sender. Again, is something you have in every Solidity method, and you don't get those in rholang. So they're going to look up that data structure, check that you already voted. This is where I might want to intersperse things, but anyway. So in our delegate thing, we're also going to give you a 2. The method takes a 2 and it can fail, so I'm going to do eject, and then it doesn't return anything. You just get an ACK when it wins. And we're going to check. Oh, so we allocated this voter down up here, And the voter is still in scope down here. So when we do this delegate thing, we're still talking about the same voter. I mean, each voter gets their own name, their own sort of, it'll be allocated 3 times if we called the give right to vote 3 times. So we can check when, when the voter 3 guy tries to delegate to himself, then, he'll lose because of this. Is that the first thing that they check? Oh, they check this. And then the next thing I check, so then I grab the map of who voted for what, and I put it right back, peek. And if you already voted, then eject. And then, let's see. Then they do this loop of, if Bob delegated to Fred and Fred delegated to Sue and Sue delegated to Joan, then you got to go through this loop, right?
Okay.
They've got a while loop there. And at any point, if you end up back at the caller here, then lose because there's a delegation loop. You can't delegate to yourself either directly nor indirectly.
Oh, okay.
Yeah. In fact, I wonder if I took this code out, if it would still work, because it's going to find out that the self-delegation down here. But it's nice. It's a little bit nicer to get a nicer message, a distinct message. All right. So we checked that the guy already voted. And now we've got our map of who's the delegate of whom. All right. And then loops in rholang, we don't have a while construct. We just have the ability to do recursive contracts, basically. So we're going to allocate a new contract, 2 new contracts, loop and finish. 2 new names, and we're going to listen on them as contracts. So we're going to initialize the loop at the bundle 0 of 2. So you're supposed to call 2 with bundles, with bundle 0 of something, but if you don't, bundle 0 of bundle 0 is the same as bundle 0. So doing it again doesn't hurt anything here. And it makes sure that if somebody forgot to, then it'll do the right thing. Okay. So we're going to loop starting at 2, and if our loop guy is the voter, then we got a loop and we eject, but we have to remember to put back the delegate channel. Careful. And otherwise, this is where, if whom has delegated to somebody else, that's the check up here. If voter's delegate is not address 0, they do it differently. They check for address 0. We check for, is the guy in the map? If he's in the map, loop again. Otherwise, call the finish doodad. And I could have put the finish stuff in line, but I just thought it was nicer. Okay, and so if you finish, and notice that loop and finish don't have return channels, so you don't return from them. We just act back this thing.
Okay.
So the finish doodad, we are going to go ahead and do the actual delegating, which is we're going to take the delegate channel and we're going to, set the voter's delegate to whom. And we're going to, act to say that you won. And then let's put this code closer. So this is some of these sort of normal programming tasks, things that look like normal programming in another programming language get kind of wordy in rholang, but anyway. We go grab the map of counts and the voter weights And if you already voted, then we go ahead and add your weight to the proposal that your delegate chose. So if I vote for Douglas and then delegate to you, and you voted for Lincoln, then Lincoln gets my votes as well as Douglas. That's kind of weird.
Right.
But I guess that's the way they designed it.
Okay.
All right. So if the delegate has already voted, no, it's if I delegate to you and you have already voted, then the thing that you proposed gets my weight. So I'm updating the proposal count stuff, and I'm not changing the voter weights in the case where the delegate already voted. Otherwise, I'm changing the voter weights and leaving the proposal counts alone. And then the winning proposal doodad is entirely straightforward. It's basically doing a max in a loop. You know, they loop over the proposals, and if you start the max at 0, and if this proposal is higher than the max, then you keep track of it. And I guess you can, instead of saying return winning proposal, you can just name the return variable, and if you assign to the return variable, I think Go has that feature too. Anyway, okay, so here's how we do it in rholang. We get the proposal counts and we put them right back. Otherwise, nobody could ever ask for them again, or nobody could vote again. And then we do a loop. And where do we actually call the loop thing? Oh, right, at the bottom. Okay, so this is kind of backwards. So we match proposal names with head, tail, and recall that at the very top, we ensured that proposal names is non-empty. So this will always match. And we call the loop with the head of the first proposal, and then as many votes as it got, and then the rest of the proposals. So here's the best guy so far, the best count, and then the rest of the proposals. And if there's no more rest, then we win. And if there are some others, then we if the rest consists of a head and a tail, then we check to see if the head of the rest is better, and if so, then we continue with that guy. Otherwise, we just continue with who we've got so far. So that's how you do a while loop or a for loop or whatever, recursive stuff. So that is the whole deal.
Sweet.
Oh, let's make one change here, and let's do we can sort of deconstruct we returned a tuple. I guess we could have returned two separate things, but I returned a tuple anyway. And then this deconstructs the tuple. So if we run it again, Oops. So now I got a syntax error, but it doesn't. But the line number of the syntax error is over here, which is annoying. Oh. So now it says the winner is Lincoln and the tally is. Oh, Lincoln got all 3 votes. Yeah. Yeah, that's because this guy's votes go in a race. Sometimes he votes for Lincoln and sometimes he votes for Douglas. Douglas gets at most 1 vote. Lincoln always gets at least 2. So Lincoln always wins. Oh, this is weird. I don't know what this is, but it goes away if I restart my node. And this says that in 815 steps, it's going to cost 76518 phlogiston to run this scenario. So to motivate and introduce the locker thing, so if we actually want to run an election, I can put the ballot contract in the registry, and we could, we could all look that up, and we could each create our own election. But what if we actually want to vote in the same election? So I'm going to call the ballot thing, and I'm going to get this this chairperson thing back, or at least it's going to be printed. But then in the example here, it's going to go out of scope and go poof, and nobody's going to be able to do anything. So I have to keep a handle on the chairperson right. But I can't put that in the registry because then anybody could act as the chairperson, right? And I certainly can't put my right to vote in the registry because then anybody could cast my vote.
Well, the registry entry itself is unforgeable, sort of, right?
No, when you stick something in the registry, anybody who knows this name can look it up.
But that name is not guessable, is it?
Well, I mean, it's guessable by anybody who's running a validator, and because they see it, it's right there in the blockchain. Or anybody who's not running a validator, anybody who looks at the blockchain. All these things are sort of guessable after the fact, but the difference between an unforgeable name and this URI is that the URI you can turn around and put it in a rholang program and use it. Whereas this is not rholang syntax here. You can't utter an unforgeable name in rholang. You can only make new ones. It's only if they're in scope can you use them. Whereas this thing is a public name, and anybody can just write that down and put it in their program. Just like a string or a number or whatever. Okay, so that's what motivates this locker concept for me. I started putting in stuff like public keys and stuff, and then I thought, oh, this is kind of boring. I don't want to have to work out public key crap for every contract. I've done it a few times.
I mean, can we look at the really simple case where you create a voter right, you want to send that to me? I don't know if there's a simpler case for that. But,
Um, yeah, I'm just thinking if I've got some JavaScript code, you can't send unforgeable names on and off the chain. Right?
Yeah, I guess the more basic question is identity. I guess that would be public keys.
Well, right. Public keys is one way to deal with with that identity. Another way is just the ability to send and receive on channels. Greg is working on the whole thing, but we could make a secure chat application where I just push buttons and drag and drop things, and you get access to private names, and there's no keys involved. If we wanted to make it secure, you'd probably have to log in with a key, but you could maybe just only use that once or something. Anyway,
yeah, I guess the private chat is the thing I'm not sure. I don't know how to do.
I haven't done this yet, but the nice thing about rholang being an object capability language is we can use all the object capability stuff that came before. Secure chat with capabilities is like 150 lines of code. There it is. Exercise. How do you spell exercise?
We would have to have some kind of shared secret, wouldn't we?
Yeah, how you boot up and stuff. They've got a whole question of pet names and keys, and there's all this stuff, but it's all been designed, and we can all just use the design. Pretty nice. Yeah, I have to be able to I have to have some secure channel between me and you to boot the chat. But once we have that, we can make GUI interfaces and drag and drop and things. You can just drag capabilities. Well, let's see. I just said that you can't send unforgeable names in and out of JavaScript. Anyway, this is the way I'm thinking of doing it. Maybe it's overcomplicated, but you want to see this example?
Sure.
Okay. So here's the example up here, and the heart of it is we're going to make a new trinket, and then the trinket is going to go out of scope, and then we're going to be able to get it back because we can read from the locker. So normally you can't access trinket outside of this new doodad unless you send trinket to someplace else. Here. So, okay. New locker, traced it out. And the idea is that you would give a public key to your locker, and then this is the return channel, and then you get your locker back. And we're going to allocate a new trinket, and then a channel for communicating with the locker, trace the trinket, and then we're going to call locker update, and this is our signature, and then a nonce, and then this is the updates to the locker. At this key, we're going to store that value, and we can do as many keys and values as we like. And then if we lose, just trace it, and if we win, come back on the ACK channel. And then if we win, because we got the ACK, we're going to call locker get, and we're going to receive there. If locker get loses, we're going to trace. I can't remember how. Oh, locker get could lose because our signature's bad. That's why we've got an eject channel. And then if we get something on the receive channel, then we're going to destructure it and pick out trinket out of the map. And we're going to trace that we won and got the trinket. So we'll run this. And there's the trinket, and win, we got the trinket back. So that's how you use it. So the idea is that you would, you might run the ballot contract in here, and you would squirrel away, your chair rights or your voting rights inside your locker. And then later you can do a signed request to get it back out of your locker and then use it. And the signed requests, the locker get and stuff you can do from JavaScript, because you can put the locker in the registry. Anybody can see my locker, but unless you have the combination, you can't access the contents of it. So it's okay to put the locker in the registry. I should have done that. Yeah, that's the next exercise, is to actually connect this stuff to some JavaScript and show it working and do real signatures and stuff. Okay, everybody have the example in mind, or anybody have the example in mind?
For voting?
Well, voting is a possible application, but right now the example is just the trinket. The trinket goes out of scope, but we can get it back. Are we good with the example, Steve?
Oh, yeah, I'm good.
Okay. All right. We're going to stick the locker contract itself in the registry. I also should put this locker. I should put that in the registry too, because like I said, that way I could get out from JavaScript. Anyway. Okay, so here's the guts of the locker. You call locker with a public key, which has to be a byte array, and a return channel. And it allocates kind of this self doodad, which is the new locker, a place to put some items, and a place to keep track of the nonce. And we return self bundled up so that you can only call it. And the items we initiate to an empty map. And the nonce we initialize to -1. And anybody can get the nonce at any point. Oops. Anybody see a bug in this? What if I called get nonce twice? What would happen the second time?
Oh, nothing would be there.
Right.
So you have to put it back.
Yep. So let's see. Yeah. Okay. So anybody can get the nonce at any point. And then to do an update, you give a signature, what you think is the next nonce, some more stuff to put in the map, a fail channel and a win channel. I just trace for sanity. I get the current nonce out, and if your next nonce is not the right one, you lose, and I remember to put the nonce back. And if you got the nonce right, then I store that in the nonce channel. That's kind of interesting. I don't check the signature before I put the nonce back in there. I wonder if that's a good thing. I think that's a good thing. there's a little bit of a denial of service attack where somebody just goes, they don't know the key, but they just go update, using up nonces, and you try to get nonce, but they're doing updates so fast that you got the nonce and it was 10, but they just called get nonce their update 3 times and now it's 13 and you can never catch up.
Okay.
Okay. All right. So our signature checking is highly sophisticated here. We check to see if dead plus the signature is equal to the public key. So the public key is dead beef, and so if you call with beef, then you're going to win, right? It's just an operation on bytes that will win if you give it the right bytes and lose if you give it the wrong bytes. But it's not very sophisticated. It's not real checking.
Okay.
I've done that a few times and I could, but it's tedious and I just didn't want to spend the time. Okay, so if your signature's no good, then we lose. Otherwise, we're going to get the items out of storage and we're going to union them with the one that the updater called and back. So that's the update method, and then the get method does the same signature dance. In fact, it would be nice to factor that out. And it gives you all the items back on your, on the return channel. So one thing that I wonder about is that when you do the get contract, the signature is only over the nonce. And I wonder if that's sort of enough stuff. Because maybe maybe I should hash the nonce, or maybe, I don't know, who knows? I probably will. In some of the wallet stuff, they hash over the return channel too, which I don't think we need to do here. That makes things a royal pain in the ass. Anyway, that's my locker idea. I haven't fleshed it out. But yeah, the next thing would be to actually check real signatures and then try to do it from JavaScript, kind of like I did the Alice Pays Bob.
Okay. Good job.
Do we still have a rholang bot?
Yep.
Is it sort of cool to send this much code to it?
Sure. I mean, it's right now it's not connected to a bootstrap, so it's essentially running single user. It's not terribly. I mean, the idea was eventually we would be running our own network, but we didn't get around to it. This node would be the bootstrap.
Right. Okay. So if I want to use it, is he here? If I do, I forget how to do this.
Yeah, that'll work. Paste it in there. Okay, that's not going to really show anything.
Okay.
Because we didn't do any. We didn't.
All right. Well, let me just do the experiment here. Let's try voting. That didn't work.
Oh, you're going to have a limit.
I'm going to, a limit, right.
That's right. And So what I've done in that case is I run the contract from the command line on robot.net, or I define the contract, and then we can use the contract in the evals.
Okay, so where's the Roth? There it is. Right? Except it's going to complain that I don't have enough parameters.
Yeah.
I forget, is that enough? That looks right. And then I also want to do the locker. Although the locker has that bug. Oops.
So you deployed it without evaluating it.
Yeah.
So we don't get to see the. We're not going to see it execute.
Well, it's going to execute now when I do propose. Oh, we won't see it, I guess, in the channel. You had some mechanism for watching the logs, didn't you?
Yeah. Okay. We do see it in the log. It's robot.net/rnode-log.
Like that?
Yeah. That's the reverse order.
Okay, so shall we run a little election here? I think we're going to need lockers, but
What? Well,
let's try it without them.
right. We're going to get. We don't have a way to get the unfortunate names, right?
Well, let's work through it here a little bit.
I guess we could. You could add robot to a chat channel and do it privately with people.
Wait a minute. What are we voting over?
About nominations for the board. Rushkoff.
And does Stood Out go to this channel, this Discord channel?
Yeah.
Okay, close, 4 chair, 4 ballot, new lookup for the odds. Am I doing something wrong?
Why don't you edit that? Let's look at it. See what could be wrong. Looks right. I wonder, there could be an issue maybe with the robot. And let me restart that. Why don't you copy that and then re-enter it, because it won't get it if you modify it.
Yeah, this is a new chat message.
Okay. Submit it.
Okay, so the robot doesn't say hi or anything? Huh.
Yeah, I should have checked that error. It was hitting an error condition at some point.
1, 2,
Now you can see line 4, 98. I don't know. Probably.
there's no bang there, and there's no bang there.
Oops.
Right.
Still got
1, 2. Oh, I didn't do it on lookup either. Ah.
Should fix robot to let you modify. You know. There we go.
Oh, so the stood out goes.
Where does the standard out go? What happened? We lost something? We didn't get any output.
Did our lookup work?
That's a likely candidate. I mean, we copy it right?
Here we are in this mode where I put a trace inside of every 4. Nope.
So if you look at the output,
Let me fix that. No, it didn't work. So is this running Casper? Is this thing connected to a, is it?
doesn't look like we got the message. We got the block proposed.
We don't have a registry. Wait a minute.
We do have a registry.
No, we don't. Wait, ballot registered at blah, blah, blah. Row ID, FE, blah, 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 blah.
Well, I've used the registry successfully. Actually, I used the URI I got from the eval, and it worked. So maybe we're not actually. It looks like we're not actually.
Oh, wait. Was I supposed to do an eval instead of a propose and deploy?
Well, if you did an eval, I know the registry works.
Okay. So what is this doing?
And the strange thing was that after I did a propose, it didn't change, but I guess it's because it wasn't working with the propose.
My propose is hanging. All right, so let me try evaluating these contracts instead. Locker is registered there. Okay. Ballot is registered there. All right, so we have to do edit, copy, escape, paste. Oops. Copy. Paste. Oh, look at that.
Sweet.
Wait, so now we got the ballot thing out of the registry, but when we called the ballot contract, it didn't work. Hang on just a sec. Um, okay. It was ballot that's registered at row ID TC9, right? Yep. Oh, each line is backwards, so I have to read this backwards.
Yeah, you could do chronological, but it's not filtered and it'll be a mess.
1, 2, 0, 1, 2, 3, 4. Yeah. And 4. Oh, it sorts them. IO comes before registry, so lookup is X4.
It looks like you're not looking it up.
The lookup part worked.
Right, but you seem to be. But that's the URI. Wait, how come it's writing the URI to the ballot? Is that what it's supposed to do?
No, I wrote a URI here. It gave me back an unforgeable name. I wonder why it didn't give me back a bundle. Did I not register? Oh, yeah, I forgot to bundle ballot. It's a security bug. I do that with Locker also. Yeah. Uh,
That's 5. Okay. Hmm.
oh, it returns 2 different things.
What?
Hold on.
Oh,
Yeah, if you don't match things up right, then it won't fire.
right. So the method signature was wrong, or the contract signature was wrong.
Okay, so we can make a ballot, but now none of us can vote because this thing has gone out of scope, and there's no way to access it, right?
Right.
The chair doodad has gone out of scope. So now let's make a wallet for ourselves, each of us. Let me need a locker. Where's locker? Yeah. All right, I'm going to build this up slowly. Val, new, lookup, stood out, row, aisle, stood out, lookup, row, registry, lookup, in, lookup, lookup, for locker, lookup, stood out, locker, locker. Okay. So each of us has to do this. Oops. Now I'm going to make myself a locker. Just a sec. What a royal pain that took us.
I've been thinking about setting up a user context for rholang,
Yeah.
so that it could like I was actually thinking of using the C preprocessor. Where you could substitute in like $mylocker, stuff like that.
Well, again, you can't utter unforgeable names, so it's going to be a little tricky.
Right.
Oops. Oh, I have to give it a key. Which way does the locker, the check go? Hang on a sec. It'd be
basically, you know, have macros for accessing things from your locker. Something. It's really, you know, the locker. It's sort of like.
Is your dog hearing my dog?
Yes. Silly. Felix. Felix. Hey. Why?
Maybe.
No, I got my yeah.
I sometimes like to do this. Put the call in the. Okay. For URI, at URI, from URI. Stood out. Devo, give it a break. There's the insert. There's the locker.
Now, you can stick something in your locker that I can get?
No, I'm going to make my own locker, and I'm going to want you to do the same thing. Unfortunately, is there a way to make this bigger?
Make what bigger?
The box I'm typing into? It's not.
Okay.
Wonder if I should put this in a file. Yeah, let's do that instead. That way other people can.
Well, when you enter it, we'll see the whole thing.
Okay, well. Okay. I'm going to edit it over here, though, because then I can balance the parentheses and stuff. Ah. RChain.
What happened?
627. Name variable RChain used in process of context at 627. Oh. The error messages from BNFC suck. Ugh. Oh. How do I get it to come out here?
I'm sorry?
Did it not work?
Why didn't we get any output? I don't know. You can hit chronological if you want to see the unfiltered version of the output.
Oh, because this is not a byte array. So the locker,
Right.
that pattern only matches if it's a byte array. Heaven forbid we should get error messages. This is life. Hey, look at that.
There we go.
Sweet.
Should I delete some of these prior errors?
Oh, yeah, let's see. Oh, because should I have deleted robots response too? I don't know if I can do that.
I'll do it.
Okay. All right. So there's my locker. Now, if I want to start an election, I got to put something in my locker. Well, can you guys make lockers, or at least one of you?
That'd be, I wouldn't be there yet. Jim, you'd have to do that.
Well, you just copy all this and change the Dan to your name.
Oh, okay. Let's see here.
Okay, so you take 3 back ticks and then eval. Then you hit enter, then you paste it in there. And then you put in 3 back ticks at the end after you change your name. Oops. I put a return in there. Oh no. Delete that. I'm gonna just I changed it to my locker. Since it says who it is.
Jim, in Discord, when I enter text into the window and I want to create a new line, when I hit enter, it submits it. Is there a way to create a new line without submitting?
Well, you want to type 3 backticks eval and then enter. 3 backticks puts you in the mode where.
Okay. Okay, I'm getting it. Okay, so eval puts me in the mode, and then
And then you have to go all the way to the bottom and put in 3 backticks and enter to finish it.
okay, all the way to the bottom, and then 3 backticks. Okay.
You're not using backticks. Backtick is next to the 1 key on my keyboard.
Oh, okay. Gotcha. Gotcha.
Felix. Uh-oh. Looks like you did the same thing I did, huh?
Yeah, let's see here.
You put a return after Steve.
Okay.
Okay, and I can.
Hey, look, Steve's got a locker.
Okay.
Okay, so now I'm going to create a ballot in a second, but I think one of the most useful things. Oh boy, this is complicated. What we're going to do is we're going to make up my inbox. I mean, each of us is going to have an inbox that we can publish. Yeah. Okay, so let me write that up here. Having to look up everything every time is a pain in the ass, but that's the only way it works. Okay, I don't need that. So this is my locker.
What happened?
What?
I deleted your code. Oh no. How did I do that?
Well, my code's here, isn't it?
Yeah, no, I deleted Steve's.
Okay.
I was deleting his error, and I guess I deleted it.
Do I need to recreate it?
No, it's still.
Okay.
Okay, so I'm editing over here. So now I've looked up my locker. And I'm going to inbox. Oh, I need to be able to insert the registry because this is going to be weird. Okay, so I'm gonna look up my locker. Oh. Okay, so we should have used slightly different keys when we created our lockers. The AAA part is the key. So here's how I create a signature with that key. Like that. I have to get the nonce right. That's what I want to update. If I get it wrong, print it out. And if I get it right, no, I don't really care. Not going to wait for the update to happen. So I'm going to insert so we publish only the ability to write to our inbox, right?
Right.
Okay.
So we publish the ability to write to our inbox, and we print out the URI we get from that. And then guess we didn't need that. Okay. We're creating secure chat in a way.
Yeah.
Backtick, 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 eval, paste, backtick, backtick, backtick.
We got a nice, we got the URI of your inbox. Great.
Yeah.
So now we each have to make an inbox.
Yeah, because I'm going to send you your right to vote.
Okay.
Just had a power failure. Something. They did it again. Updated it at the bottom. I put my inbox because it says my name.
That didn't go into your inbox because it says expected nonce 1.
Oh,
Have you used your locker already?
no, I used your locker. I goofed.
So yeah, we need to put in our own key that we created, correct?
Silly
So-
me.
So we need to go back and find
Well,
that.
Yeah, the registry URI. Oops. Oh, you tried to write to my locker, but you used the wrong nonce, and so you lost. And it was kind of like you got the wrong signature. It's a good thing we stood out as the eject channel. Oops.
Let's see.
PNCE. PNCE is me, Henley.
Okay.
Let's see. Your
Yeah, I need to get my ID here.
yeah, your ZFZ. We should give all these objects friendly names for debugging. So when it says locker update, it would say Dan's locker update, you know.
Right.
Locker name.
Jim, did you make yourself an inbox?
Oh, I have to hit return, I think. Did I just right? That's
So you're N953. Yep, so there's your inbox.
uh-oh.
You just made another locker. All right. Steve, let me move ahead.
Steve didn't get another locker name though. What happened?
Good question.
Well, it may have been in my copying pasting. So did you want to move on, or do we want to continue to figure this piece out?
Let me move on a little bit here.
Okay.
What is TC9? Right, ballot is TC9. Okay. I'm going to look up ballots, and I'm going to create a ballot, and I am going to look up my locker and save the chair and get winner in my locker. Let's see. I guess I should use the next nonce. Okay. Now I'm going to give Jim a right to vote. This should be fun. So, Jim, this is your inbox, right?
Yeah.
Okay, so I have an inbox now.
Yeah, cool. So I've got Jim's inbox. Might as well look up yours while I'm at it. And I'm going to look up my locker. I was going to do you guys in parallel, but I need to get the nonces right, so I'm going to do them in series. Oh, no, I guess I got to do them in series. Okay. Slightly less confusing order here. For locker from RChain. Locker get sign it. The next nonce is 2. Items as a process from items channel. Then items, oh, actually I could destructure it like this. That's chair as a process. This gets pretty boring. So I got my locker, and I'm going to get my chair right out. I'm going to make a Jim vote, look up his inbox. Oops. And send Jim his right to vote. Likewise. Oh, how long am I going to be able to paste, I wonder. We'll see. Maybe I should just do one. What are the odds? Drum roll.
Yeah.
So that I can count line numbers. Yep. What did I do? Oh, I wonder if this is cool. No, I want to do @chair because this is going to give me a process, and I want to send on a name. Ah. But 6B F1. Six BF1. All right. Put a debug after every 4. Oh, I'm missing this thing. The fail channel on get. Now who knows what the right nonce is?
Where? Sort of lost the train here.
What did I do?
Did you eval?
I did something wrong there.
Oh. Mm. Avoiding.
Oh. There are other things in this map, and that would only match if there was only one thing in the
Okay.
map. Hmm. Nope. Expected nonce 3.
I was going to guess 3.
Okay. Now let me send Steve's right to vote.
What's the
Oops. Steve, your inbox is 5XG.
Let me go back and check. Yes, 5xg.
So I was going through a lot of work here for nothing.
Be careful how you use that inbox for a second, Jim. Okay, so now Steve's got to vote. Okay, so, and I guess I could since I'm the chair, I could give myself a right to vote and exercise it, but that's going to look different from what you guys have to do. So let me try to, let's see, Steve, your locker.
If we can get our inbox, we don't have to get it from our locker, right? Because we know it's registered. Oh, it's registered as right only, though. Never mind.
No, I did not register your right to vote.
My inbox is registered.
Right.
But it's right only.
Right.
So I have to get it from the locker in order to read it.
Bingo. So there's Jim's locker. I'm going to show you how to exercise your right to vote. Yes, we have to register. Might as well print things. I don't remember. Um, if I copy this without putting, oh, if I don't do eval, so Jim, if you copy and paste that, do you want to exercise your right to vote? I mean, I could have exercised your right to vote because I know the key or our signature checking is not robust, but oh, I didn't print anything. Oh, maybe the voting thing will print something. Yeah. So Jim, if you eval that code, the nonce may be wrong, but I assume you want to vote for R. Crap. Line 5 is bad.
The bang is missing.
Yeah. I suppose you can fix that as easy as I can.
Yep. Oops, I hit return again. Silly me.
Oh, yep.
What's wrong?
Inbox is a process, and we listen on names, so we got to quote it.
Oh, I'm looking in the wrong place for the error. Inbox. So we need to say at inbox.
In this for thing.
Yeah. Oops. I screwed up. What'd I do?
Oh. Line 7.
He needs the at in front of the
the at in front of the inbox is what we need you to fix. Oh no, this you don't want an at here. It's this line where you want the inbox, the at sign.
Okay, so yeah, that's got to be that's a process. Inbox here. I want to. Why am I confused? I'm going to do the inbox is the process. I'm going to read on the name. I don't know what I'm doing.
Yeah.
There you go.
Eh.
6.
Oh, that should be Jim Locker Ch on the other side of the arrow there. This one here.
Yeah. Oops.
Oh, now you got your extra apps on here.
I'm screwing up with my copy paste, huh? Wrong things. And now I get no output. We didn't output anything. Huh? No, it should have output something. You know?
Oh boy.
Oh, I, so do we know that it didn't do it, or do we think maybe it did? And if we do a vote, we should see it.
We're missing a stood out here. I don't know how you deleted that.
What?
Get takes. Oh. Get has a eject channel.
Okay, so somehow we missed that.
That was me. So you need to add star stood out before star items ch.
Whoops.
Ooh, look at that. You voted.
Hey.
All right.
Sweet. Now I just have to clean up the mess I made.
Let me see who's winning at this point. Oops.
Oh, you can't see the right thing.
Expected nodes 5. By the way, if you use an editor with syntax highlighting, I use Scala mode to get this. It's not rholang mode.
Right. Yeah, I do the same thing in VI.
Right.
Syntax equals Scala.
Look at that. So I could give you a right to vote, Steve, and we could go through all this hassle and blah, 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 but you get the idea, right?
Yeah, I got it. That was great.
So
Cool.
what does it do if there's a tie?
It picks arbitrarily.
Yeah.
Because it's going to
Well, we've been at it almost 3 hours now, and say it was highly successful.
Yeah.
We got to see this process and a real application of the locker. Sweet.
Yeah, you can put purses and all kinds of things in there. They don't have to be wallets. You can put raw purses inside your locker, right?
All right. Now, I guess the one problem we have is, well, yeah, we have to complete the security there, but
What do you mean?
the part where we use the real public key or private key.
Oh, right. Yes. The real signature stuff I have not done. But this is definitely motivation to do it because it's pretty clear that it should work.
Sweet.
All right. Thanks, guys.
Yeah, thanks, Dan. We appreciate it.
I do some more thinking about how the robot might help a person. That's an issue.
Help
Yeah.
help a person in you mean in this process of coding and debugging?
Yeah. Well, really, actually, really using these contracts from Discord is what I'm talking about.
Oh, okay, okay. So
where it could keep information.
yeah, we have these tools now. What's the application? How can we incorporate that into our routine?
Right, and well, I mean, it wouldn't be really secure, but I mean, if you if robot knew your private key, for example, could handle the encryption for you.
Okay. Right. So, is there so right? So we created the locker, or yeah. I was just trying to think how we might. Are you thinking how we might be able to incorporate Dan's voting contract into Discord to to use that?
Well,
yeah.
Not only that, everything.
Yeah, everything. Right. Well,
no, the idea would be that you could use macros to make things easier in some way.
okay.
And, would have to. I was thinking of CPP, but perhaps there, some other process could be where you could like define names, either personally or globally,
Okay.
to run contracts and such, so that in essence all the there could be a lot of stuff predefined for you that you wouldn't need to define. You could
that specific to that user.
Well, thinking I mean, it could be user channel.
Okay, right.
Global.
Okay.
Global channel.
Yeah, multiple levels. Okay. Yeah, so I think as these smart contracts are created, so it's how can we incorporate this functionality into the Discord, into the robot, or into Discord somehow to expand its functionality and capability.
Make it easy for us to use, basically.
Right.
So that we could define the contract and have robot know its name and URI.
Okay.
And
have robot know the name of the contract.
Yeah, like
okay.
We defined ballot today. We have a URI for it.
For I'm sorry, got cut off there. For eval, you said.
I was saying, we created ballot.
Oh, ballot. Okay.
And we got a URI for it.
Oh, okay.
Okay, so in essence, what I'm suggesting is robot remembers that.
It- okay. And is there does it have is, so for ballot and for additional functionality in smart contracts, is there so is ballot, is that being stored somewhere? How does it know how?
Yeah, it's not stored anywhere now.
Okay.
Um, and I'm not sure how I would have it stored. Um, I mean, there's a couple of ways to do that. Um, uh, it could be done, more or less explicitly with uh, where you would say define ballot and put the row ID there.
Right.
But actually, it's more than that because you sort of want to take all these defined things and read them.
Right.
And I guess that's too much.
Well,
I'm
all
looking at for an easy way to make it easier to use this.
well would Mattermost, would that allow us to store ballot and give us additional functionality to incorporate these smart contracts?
Um, there wouldn't really be any advantage in that uh, directly.
Yeah.
Of
Well,
course,
is there
I would want to put the robot functionality in Mattermost as well. But
right? Well, to store the ballot smart contract, is there a way to store it somewhere outside of Discord so Discord can go and retrieve it and pull it in and uh, to incorporate it that way?
actually, I was thinking of using the preprocessor, which would work either way on Discord or on Mattermost. It wouldn't matter.
Okay, and
The the no, so the issue would be, how would I know what to define? And if I
this preprocessor, is that a function of
uh,
Discord, or what is that something you created?
um, I would use a preprocessor like CPP,
Okay.
the C preprocessor is what I've been thinking about using. So in essence, when you put in your stuff to eval,
Okay.
it would put in a bunch of pound defines
Okay.
and some prefix code, and then some encode after what you put in.
Okay.
And the pound defines would let you put in $ variables into your code.
Ah, okay.
They would be replaced by the preprocessor
Okay.
with the URIs, for example.
Right. Okay.
So you could like use dollar.
Yeah. So then you can have all these predefined variables in Discord now.
And what I would really like to do is capture, I would almost like to capture it more automatically, but there's no reason you couldn't just put a define. Like you see something here, you see a lookup here, and you have, you could do something like, let's just say, uh, slashes it uses already, so we don't want to use slashes. Let's say we can use a prefix like we actually could do anything. We could say define,
Mm-hmm.
well, and we could say uh, the syntax we come up with, but we could do something like this.
Okay.
Okay, so then when I did that define, they would actually store that in the prefix file.
Okay. So if we would define that as define gym locker, so now that's defined. So you have your own predefined gym locker instead of instead of a general locker, and we can create like define Steve locker, and everyone could have a locker.
Right. And I guess the other thing I was thinking of is we could have another thing like my, which would only define it for yourself and not for everybody. I don't know.
Okay. Yeah.
On one hand, you might want to do that.
Yeah. Okay. Well, okay.
It could be something like only admins can define it globally,
Okay.
but anyone could define their own.
So with the CPP, would that interface with Discord, or what is there a connection between those two?
Well, CPP is a pipe. It's something you pipe into with Linux. So I would essentially pipe in this what they put into CPP. And it would include a header and a footer automatically.
So I'm trying to understand this concept of CPP. So it's CPP is a pipe. So it's a pipe going to where?
Well, goes wherever we want. I mean,
okay. So you'd have these criteria, these definitions stored somewhere else. CPP would be this pipe that connects to 2 points, connects Discord to this other location. Am I describing it correctly? So
okay. If I do a pound define, locker, this, I don't know if that works with the quotes or not. I don't even know if I remember this. When I do a colon, row. Okay, and then let's say I put in I put in something like Is that right? No, I don't. I forgot how to use CPP.
I'm not familiar with it. So are you on the back end of your robot?
Yeah, well, I was just
So, oh,
doing.
so on the back end of of the robot, can we make definitions there? And then so it's like teaching robot to remember definitions.
Okay, so it's no $sign. That's I have to remember, but I put this in there by I had a define locker here, and then I use locker here.
Okay.
And I guess I could put this could be part of something like a 4. This is a bad example. I'm just trying to give you an idea.
Yeah.
I don't know if CPP may not work, but there is some preprocessor I can use.
Okay. Well, yeah, maybe
that would work. Well, you see how I put in the where I put in locker here and put in the name. That's the basic idea.
Okay. Right.
All of these defines would be done first, and then it would do your program.
Okay.
And it would make things easier.
Yeah.
But it's still, you know, it's I'm still thinking about it. But I guess it's late, so we better go.
Okay. Hey, enjoyed it, Jim. Thanks for hosting.
Sorry, glad you came.